Okay, so we are going to start calculus. So we are going to do it in 3 sessions, actually 2 sessions. The limits and differentiation in this session, and another session we are going to do the integration. Okay, so but we can subdivide it into 3 parts. That is the limits. That is the theory part, right? Limit. Then we have the differentiation, and we have the integration. Okay, so those two are the applications. Limit is the theory, then we have two applications called differentiation and integration. So first we are going to do the limit part. So I have uploaded 2 documents for limit, one document, and differentiation another document. Let's see whether we can finish this part. Okay, right. So this is related to the topic that we have already discussed, that is sequence and series, right? So that knowledge we need when we are moving with the calculus, but calculus is a separate topic as well. Okay, right. So the term calculus, uh, or the concept of calculus was developed in 17th century, not long time ago, by Isaac Newton and William Leibniz together. Actually not together, they separately developed that concepts sort of independently. Okay, so 17th century means not very long ago, about 400 500 years ago. Okay, right. So the term calculus means that the term itself means small pebbles, right? Small pebbles. So sometimes we call it calculus, sometimes we call it uh, infinitesimal calculus, right? So those two words are used. Yes, for short we just use calculus, but the long name is infinitesimal or infinitesimal calculus. So this infinitesimal is the opposite of infinity, right? Remember, we have a term called infinity, right? Infinity. So that means very large, right? Very big, infinitely large. The opposite of infinity is infinitesimal, right? Infinitesimal. Infinitesimal means very small, right? So here, how large? Very, very large. Can you quantify it? Can't. Similarly, infinitesimal means very small. How small? It's very, very, very small, right? So we can't even quantify it, right? It's even beyond that. So that is the meaning of infinitesimal. So here we are talking about small things, right? Remember, in uh, sequence and series we discuss about the infinity, right? So infinite terms, summation up to infinite terms, etc. Here we are going to discuss about small things, right? Small change, right? So how small? Very, very, very small. It's very close to zero, and so we use that concept to build the calculus. Okay, we use that concept to build the concept of calculus, right? So I am going to do it in very slowly, because I know that not everyone has done your maths in your A level, and a lot of students think that calculus is difficult subject. So calculus is very simple subject. Only thing is you have a lot of, some of the students have a lot of fears in their mind, and some people have induced that calculus is a very difficult subject. No, calculus is just another subject like logarithms or trigonometry or whatever. Even the calculus is not considered as advanced maths, it's intermediate maths, right? So therefore, right, so in sometimes back, actually calculus was taught in O level, right? In 1970s, actually before us, our generation, in 1970s they have taught calculus in O level even in Sri Lanka, right? So then only they moved it to the advanced level math syllabus. So you can see that it is something you can understand. I mean the basic things. Okay, basic things, right. So calculus is all about understanding some concepts using the concept called infinitesimal, small quantities. Okay, right. So let's move on. So there are two applications of calculus, that is differential calculus, so differentiation, and integral calculus or integration. So those are the two applications or the two major branches of calculus. But before moving to those two, we are going to discuss the concept of limit, right? Concept of limit. Actually, there's interesting thing also, that is these two branches, right? These two branches, the differential calculus and integral calculus, are interrelated. Interrelated. So those two concepts are interrelated by the fundamental theorem of calculus. Right? Fundamental theorem of calculus. Whenever you hear something like fundamental theorem, that means we are not going to prove it. It just happened to be like that. So that is the term fundamental, right? So it happened to be that integration is the reverse process of differentiation. Differentiation is the reverse process of integration. So that is an interesting phenomena mathematicians found. So they basically developed those two concepts parallelly, but after sometimes they found that interesting feature. Obviously, integration is the reverse process of differentiation, or differentiation is the reverse process of integration. So that was a good thing, right? It reduced a lot of burden from our side to learn the subject also, because simply it's something like, if I say the differentiation of sin x is cos x, that means integration of cos x is sin x, something like that. Okay, if I say differentiation of x squared is 2x, the integration of 2x is x squared. So that happened, that they found, that mathematicians found that those two concepts are related. So that is good, that is good. So those two concepts are interrelated by now they just gave it a name called fundamental theorem of calculus, right? So therefore, once you understand differentiation, it's very easy to understand integration, right? So and also vice versa. So highly related concepts. Okay, but two concepts. Okay, right. So let's move on. Now we are moving to the concept of limit. Okay, concept of limit. Remember when we were doing uh, statistic course, so we discussed that there are two type of functions or entities, what is known as continuous entities and discrete entity. By the way, if you have encountered anything that you can't understand at any point, please raise your questions then and there, and don't tell at the end that I didn't get anything, right? So if you didn't get anything in the 10th minute, so you have to raise that question in the 10th minute. Don't say that at the end I didn't get calculus, right? So that means you have a lot of fears in you, right? So you, if you feel like I can't understand, yes, you are not going to understand, right? So that is why I'm talking telling whenever there is an issue, you just have to clarify, otherwise that means you are okay. Okay, right? So there are continuous things and discrete things, right? So we discussed this under, right? We discussed this under uh, statistic as well. For example, a number of students in a class is a discrete thing. So all of a sudden one become 2, or 2 become 3, or 3 become 4 if two students come. So those are discrete concepts. Discrete concepts, right? But there are continuous things like temperature, height of a person. So those things grow or shrink continuously, right? Without any gaps. Without any gaps. So in mathematics, we identify those two as continuous functions and discrete functions. For example, temperature is a continuous function, right? Whereas population of a country is a discrete function, right? Or something like that. Okay, something like that. Okay. So when it comes to continuous things, so when it comes to calculus, it is related to continuous things. So that is something you have to understand. So calculus is all about continuous things, right? Sequence and series is all about discrete things. So now you can see sequence and series, it's discrete thing, because in sequence and series we say 5, 7, right, 9. Now you can see after 5 it is 7, after 7 it is 9. So it's all about discrete things. But calculus is, we are going to discuss, is all about continuous things, right? Continuous things like y equal x or y equal x squared, something like that, right? It's a, you know that it's a continuous thing, right? It continues to go like this, or it continues to go like this, right? So it's not like this. It's not like this. So we are going to discuss about continuous things in this particular topic, right? So I'm just setting the background, right? Okay. So continuous means there are no gaps. It's like flow of water. Okay. So concepts like volume versus time, pressure versus time, right? So these are, so the related things are the calculus. But discrete things means number of students versus time, population over a time, right? So concepts are sequence and series, sets, matrices. So those things are related to discrete entities, right? So what we are interested is continuous entities because our topic is calculus. Okay, right. So remember in statistic also we subdivided it into statistics related to the continuous things, statistic related to discrete things. Actually we have completed the statistic related to the discrete things. We are just waiting to complete the calculus to move on to the statistic related to the continuous random variables, right? So you can see we are why we are doing calculus. Another reason is we want to continue with the probability distributions of continuous things, right? Like temperatures, etc. Right? Okay. Right. So now we are going to just build up few background, right? Few background. Again, the prerequisite is you must have aware of the basic concept of numbers. What are the different type of numbers? Then the concept of relations and functions that you have learned in your semester 2. What is a relation? What is a function? Right? Then special numbers also we need to understand, like 0, infinity, and basics of trigonometry, right? So what is trigonometry, why we have trigonometry? Because we are going to do some work with trigonometry functions. Actually trigonometry and calculus has no direct relation, but we are going to do some differentiation of trigonometry functions, etc., right? Then some other basic concepts like what is mean by logarithm value, and what is the graph of the log x versus ln x, what is the difference between natural log and the general log. So those things you have to understand, right? So those things we have done in your semester 1 and 2. So we need those concepts to better understand the concept of calculus. Okay, actually the more than to understand the concepts, in order to apply those concepts we need those other concepts. Okay, right. So first we are going to discuss about the concept of 0, then we will be discussing about the concept of infinity, and then we will move on to the concept of limit gradually. Okay, right. Right. So we know that the 0 means it represent nothing, right? It represent nothing. So we need some way to represent nothing. So in mathematics we represent nothing as 0, right? So 0 is a number in maths, and it's a number which is neither positive nor negative. We know that if you take any number, it is either positive number or negative number, but when it comes to 0, which represent nothing, therefore it is neither positive or negative number, right? Sometimes we call 0 the additive identity as well, right? Additive identity as well. The reason is when you have a number, finite number, if you add 0, it results in the same number, because 0 means nothing. So therefore we call it uh, additive identity, right? Additive identity. Similarly we have multiplicative identity, that is 1. So additive identity is 0, multiplicative identity is 1, right? So for example, if you have a number, if you multiply it by 1, what you get is the same number. Similarly, same as when you add 0 you get the same number, when you multiply it by 1 you get the same number. Therefore 1 is called the multiplicative identity, right? Multiplicative identity. 0 is called the additive identity, because when you add 0 to a number, it doesn't change the value. Okay, it does not change the value, right? So those are very simple concepts, right? Then there are some properties of 0, right? So it's the subject of calculus is all about understanding the properties of 0, properties of infinity. Then we will gradually build the concept of the limit. Okay, right. So when you add, so assume that x is a non-zero finite number, so that means it is not infinity, it's a finite number like 10 or 10.5 or minus 100.2 or 2 by 3 or something like that. So when you add some 0 to finite number, it results in the same value. So that is the because nothing, when you add nothing to something, it is that something, right? So when you subtract 0 from a number, it will result in the same number again, because when you subtract nothing, it's not going to change it, right? Again, when you subtract something from 0, it is going to be negative of that value. For example, if I have 0 and if I subtract 50, the result is going to be minus 50, because now there was nothing, but now it's something like a something I owe or something I debt. Okay, so that is so those are common sense that you have been using from your school level maths. Okay, so the next thing is, if you have 0 and if you want to divide it by a finite value, again the result is going to be 0, right? Because nothing you divided into people or divided into other portions, it's still going to be nothing, right? So it's still going to be nothing. So I can divide 5, right? I can divide 5 but among 2, that means 2 and half, 2 and half. If I have 10, I can divide it by 10, that is 1. But if I have nothing, if I divide it by say 1, it's still nothing. If I have nothing and if I try to divide it to 2, both the people are going to get nothing. So likewise, if I have nothing and if I want to divide it by a finite number like 10 or 100 or whatever, anyway it's going to be nothing, because no one is going to get anything, because nothing I am distributing, right? I have no money, I have no money, I am distributing those money among 100 people. So how much they are going to get? Each is going to get nothing, right? So same thing, right? So it's all about understanding these small things. If you understand these small things, ultimately you will find that okay, calculus is a small thing. But if you are not serious about these small things, so that is the issue. If you are not serious about those small things, ultimately you will say okay, I don't understand calculus, right? Or you will say okay, calculus is a big thing. No, calculus is a collection of these small things, right? When you understand these small things, all of a sudden you have understood calculus. Okay, right? So let's move on. Right, and if anytime you lose my voice or the screen, just let me know, right? So the next thing is, if you multiply something by 0, it's again going to be 0. So that is also common sense, that is also common sense. If I have something like 1000, if I multiplied it by 0, it's going to be 0. So that is also common sense. So we have discussed these things now, right? So the next one is again interesting thing. Anyway, we briefly discuss these things under sequence and series as well, but here now we are going to discuss it in a very serious manner. Simple things we are going to discuss in a serious manner, that's it, right? So after some time we will say that the subject is calculus. Okay, right? So the next one is, if you if you have something and if you want to divide it by 0, right? If you have something, you want to divide it by 0, the result is infinity. So that is something that you have to understand properly. Say I have something like 10, right? So I have 10, I want to divide it by 0, so the result is infinity. Result is infinity. So how do we understand this? Now this is where you have to understand the pattern, right? In maths you have to understand things in two ways. The first way is you have well defined logical concept, right? Then from that logical concept we can deduce another concept, right? So we say that it's a theorem, right? Theorem. So we have well defined concepts, from that we deduce logically the other concepts, so we call it a theorem, right? So for example, you know that something like this, so these two angles are the same, so that is not a theorem, that is a fact, right? Anyone can see it, right? Anyone can see it. Then of course when you have something like these parallel lines, this angle is same as this angle, right? So that is not theorem, that is something anyone can see, right? It's a logic, right? It's a phenomena. But using these small things, all of a sudden you can prove other things. For example, you can prove that so the summation of these two angles is same as this angle, so that is something you can prove, right? So that is not something you want to appreciate or just you want to get take it for granted. You can prove that summation of these two angles is same as this angle. So how to prove that? So uh, that is something you can do using these small things, right? So how to do that? So let's do that. Say we have triangle. Let's call this x, let's call this y. So what I'm going to do is I'm going to extend this and I'm going to write a parallel line like this, right? Then we know that this angle is same as this angle, right? Because that is something you can see, right? And also you will see that this angle is same as this angle, right? Again parallel lines, right? Parallel lines. Now you can say that okay, this angle plus this angle is same as this angle because this is x plus y. So that is something we can prove using those small concepts, small concepts. So there are things you have to accept. Accept means you have to think and appreciate that yes, that is correct. So that is, those are the things like this, right? So this is something you have to accept by doing your own logical thinking, right? So this is something you have to accept doing your own logical thinking. So these two angles are the same, right? So similarly this is something you have to accept by your own logical thinking, not because someone tell it, right? You have to understand it, appreciate it, right? Convince yourself that okay, that is logically correct, right? So that is the starting point. Some people, what happens is they don't do this, right? Either they don't understand this or they don't think enough on this. Then they will see that okay, they suspect this, okay, they suspect this, sometimes they suspect this, sometimes they can't understand this, right? So that is why I keep on telling, right? So you have to be very serious about these concepts. So I am again telling, if you divide something by 0, it is going to be infinity. So how to understand this? So as I told you, there are two ways you can understand things. uh, Things that it straight away go into your mind and say that okay, that is correct, so I can see that it is correct, right? So that is one thing. Of course the other thing is using those things you can deduce, right? So that is called theorem. So the other thing is, of course, things that you can straight away see. The other thing is you can understand that by looking at the pattern. So here there is no pattern. Straight away you can understand, yes, these two angles are the same, but there are things you have to understand only by looking at the pattern, right? By looking at the pattern you can see that okay, so this is going to be correct. So that is all about the idea behind calculus, right? So look at the pattern and understand that okay, that is going to be correct, right? That is going to be correct. So the first thing you are going to understand like that. So these things, of course, you don't need a pattern, right? So you know that when you add something to when you add 0 to something, it's going to be 0, right? So it's common sense. But this is where you are going to start understand things using patterns. Okay, so let's see how this is getting infinity. And of course we know that infinity means very large value, very large value, right? Okay, so let's see. So let's see what we can do is uh, let's take an example, right? Let's take an example. So it's all about limit. So I'm not talking about limits. Okay, so let's say I have 10. So let's divide it by 10. So the value is 1. Now I am going to make it close and close to 0 because ultimately I want to divide it by 0, right? So 10 is not 0. Now I am going to divide it by 5. Now it's closer to 0 than 10. So what I get is 2. Now you can see it's getting bigger. Of course it says it's infinity ultimately, right? Now I'm going to divide it by, I'm going to make it even closer to the 0. That is, I am going to divide it by 1. So it's any number you can take. Now it's 10. Now you can see it's even bigger than 2, right? Now this is getting closer and closer to 0. 10 is 5 is closer to 0 than 10. 1 is closer to 0 than 10. So now let's keep on doing that. So now I'm going to divide it by half because half is closer to the 0 than 1. Now it is 20, right? So let's divide it by 1/10. 1/10 is even closer to the 0 than half. So now it's 100. Now you can see it's getting bigger, right? So 10 divided by let's say 1 over 1000, right? So that means 10000. Now you can see it's 10,000. It's even bigger than now it's getting bigger. So now you can see when this is getting closer and closer to 0, right? Now 1 over 1000 means very small amount, right? When one over 1 upon million, 1 upon billion, so this is getting now billion, trillion, right, etc. Now you can see when this is getting closer and closer to the 0, getting smaller and smaller, this is getting bigger and bigger. So how do we represent the concept of the very large thing or very big thing? Using the infinity. Of course, therefore we can say that something divided by 0 is ultimately going to limit or reach to infinity, right? So when things are getting closer and closer to the 0, right, this is getting bigger and bigger. How do we represent the concept of very large thing? The concept of infinity. Okay, so that is something you have to think, right? Think, right? Then you will feel like, okay, so this is getting bigger and bigger. In maths we represent the concept of very large thing, infinitely large thing, as an infinity. Therefore this is not logically wrong, this is not logically wrong. So therefore we have to accept that something divided by 0, actually it is not something divided by 0. When something divided by a number which is getting closer and closer to the 0, the result is getting bigger and bigger, so we represent it like infinity. Okay, we represent it like infinity. Okay, so this is how you actually how we really write this, right? So this is how you write this basically. So this is informally written. So we write this something like this. So assume that x is a finite number. So we say that limit, right, x divided by x is a finite number, right? So let's say something like this, limit. So assume that x is a n, let's call it something like c, right? Something like c. Okay, k divided by x when x is reach into 0, because right, when x is getting close and closer, that is what I did, 10, 5, 1 half, 1/10. When it is getting close and closer to 0, we say that the result is equal to infinity. Actually, because we are using this limit concept, we can just write it as equal, but the reality is this is getting closer to the infinity, getting closer to the infinity, but you can just write it like this in the mathematical notation. So this is what the reality is this one, but casually we can write it like that, right? We can write it like that. We casually say that something divided by 0 is infinity, but reality is when that something is getting closer and closer to the 0, the result is getting bigger and bigger. So the bigger and bigger things, or the very large things, we represent using infinity. Okay, so that is how this happens. So you have to appreciate this, right? So now you can't argue saying that no, it is not going to be infinity. So I will show you taking some examples. No, it is getting bigger. When things are getting bigger and bigger and bigger, we say that we have a concept called infinity, right? We have a concept called infinity. So therefore you have to accept that. Okay, so not because I am telling, so you have, that is something you have to do by yourself. Okay, uh, take a calculator and think about it, then you will feel like, okay, yes, this is something correct, something correct. If you have very large thing, if you represent the concept called infinity, yes, we can call it infinity. Okay, okay, so that is the first limit. Actually you learn the first limit, you learn when something is divided by a number which is, when it is getting closer and closer to 0, the result is getting bigger and bigger, we can call it, it reached to infinity. Okay, it reached to infinity, right? Okay, so the next one is again the sign matters. If you are dividing it by a positive thing, it is getting closer and closer to the positive infinity. If you are dividing it by a negative thing, it is getting closer and closer to the negative infinity. So that is another thing. So that is serious. Now again you are thinking, right? So something like this. If you have divided 10 minus 10 divided by 10, it is minus 1. Now I am dividing actually I am making it closer and closer and closer to what? 0 from negative side. So actually I would have written like this, not here. So I'm going to say I'm dividing it by minus 10. Right? 10 is my number. I'm dividing it by a negative number. Now it is minus 1. Now I'm going to say 10 divided by minus 1. That is minus 10. Now this is from negative side. Now you know the number line. This is where your 0 is. Earlier I came from this side. 10, 1, half, like this way. Now I'm reaching from this side. Right? So minus 10, minus 1, minus half, minus 110. You can say I'm coming from negative side. Right? So 10 divided by minus half is minus 20. Right? So likewise, now you can see this is getting bigger and bigger. I am reaching it from the negative side, not from positive side. When I am reaching it from the negative side to the 0, this is getting bigger and bigger, but the sign is negative. Now you can say we can say that x divided by 0, when we reach the 0 from negative side, it is minus infinity. Now you can see all of a sudden when you reach it from here, it is plus infinity. When you reach it from here, it is negative infinity or minus infinity. So that is something we have to understand, right? So therefore you can't just say okay, it is just infinity. No, depending on from where you are reaching it, from the left side or the right side, the result is either very large positive number. On the other side, it is a very large negative number. So that kind of seriousness you have to be there. All of a sudden you can see okay, it is not that just infinity. Depending on from where you are reaching it, it can be plus infinity. Of course, that is you are coming from this side. If you are coming from the other side, it is getting bigger and bigger in negative way. It is going to be negative infinity. So those things you have to just do some thinking, right? Spend some time and understand. Of course, these things you can understand, right? These things you can understand. Okay. So now how to represent this concept is, so we say that limit x tend to 0 from positive side, right? Positive side. So that means this way, this is right. Then we say some number c divided by x is positive infinity, right? Similarly, limit x tend to infinity, sorry, x tend to 0. Now this side, and from negative side, right? C divided by x is minus infinity. So that's something you have to understand, right? So earlier we just thought that okay, it is going to be infinity. No, now we know that if you are coming from this side, it is plus infinity. If you are coming from this side, it is negative infinity, right? So you can see it's all of a sudden so the plus infinity and negative minus infinity are two different concepts, right? Plus infinity means I have a lot of things, right? And negative infinity means I have a lot of things to pay, right? So it's a negative thing, right? So you can see all of a sudden it's something else, okay, right? So if you want to draw, now you can use these concepts to draw graph also. Now you can think that 1 over x graph is something like this. That is, when you are reaching from positive side, it is getting bigger and bigger. It is getting bigger and bigger, something like this, right? Something like this. But when you are reaching it from to the 0 from negative this side, it is getting bigger and bigger, but negative way, right? This is y-axis, so it is getting bigger and bigger, something like this, right? So actually it's something like this. Now we know that it's something like the graph is something like here, this way, it is something like this way. So likewise, once you understand these concepts, you can start plotting the graph also. Actually, that is what we are going to do at the end of the differentiation topic. Given a form algebraic functions, how to draw this kind of a graph or plot or sketch. Okay, so still we can't sketch the rest of the stuff, but at least now you know that it is going to be something like this, and here it's something like this. Okay, so all of a sudden you will understand how to draw these kind of graphs, right? These kind of graphs, right? So complex weird graphs you will be able to draw once you understand the concept of limits and the concept of differentiation, etc. Okay, right? So but remember, if you have not done your maths in A level, what you have learned is something called the straight line, right? And the parabola or whatever, right? So that's it, right? In your O level. But once you understand these concepts, actually all of a sudden you can draw anything. Of course, you know the EX graph and the LN graph also in your semester 1 and 2. all of a sudden you will be able to draw any graph, or actually sketch any graph by using this concept of limit and then the differentiation. Okay, right. So you can see it's a very good tool to have in your thinking. Once you have the knowledge of limit and calculus, all of a sudden your mathematical knowledge is going to be broadened heavily, right? So all of a sudden things that you were not able to understand previously, now it's going to make sense more, right? So that is good, that is good. Okay, right. So again, I'm doing it very slowly because I know that it needs a lot of time, right? Right. So now we have discussed these through, right? So the next one is x to the power 0 is 1, right? X to the power 0. It's another limit actually, right? So I will just connect my tablet. If you lose my screen, just let me know because I am connecting a lot of devices. Right. So the next one is x to the power 0, right? X to the power 0. So it's again, let's try to discuss understand that what happens when x to the power 0 is there, right? X to the power 0 is there. Again, what we are going to do is we are going to take it as x to the power n, and we are going to make it closer and closer to 0. So how to write that? How to write that? Limit x to the power n, or let's take it something like let's take it something like, let's take it something like some, we have some value called c. We want to take c to the power x, right? But we are going to make this x getting closer and closer to the 0, right? Getting closer and closer to the 0. So how can we write it? Limit c to the power x when x is getting closer and closer to the 0. What will happen? So what we want to do is see what is this. You know that and if you have a number and if you raise it to the power 0, it is 1. That something you have accepted. But now let's see whether that is going to be the case, right? Whether that is going to be the case, right? Right. So again, what we have to do is look at the pattern. Look at the pattern. So let's see that c is something like 10, right? 10. So you know that 10 to the power, say, let's take some. So let's make it 10 to the power 1 because 1 is closer to the 10 0 than 10, and that is 10. Now you can see it's getting smaller. Now let's take 10 to the power 0.5. 10 to the power 0.5. So if you take a calculator and calculate, so let's take the calculator. So 10 to the power zero point 0.5, that is 3.16, right? 3.16. So it's smaller, it is smaller. 3.16. So similarly, if you want 10 to the power 1/4, that means if that number is multiplied 4 times, you get it. Or 10 to the power 0.1. So let's see 10 to the power 0.1, what will happen? So you have to spend some time, right? You can't learn calculus in a hurry, right? So that is another mistake people make. So 10 to the power, right, x to the power y, right, zero point 0.1 to 1/10 means 0.1, and that is 1.25 something, right? 1.25, 1.25 something. Now you can see it's getting closer to the 1, right? Actually this says x to the power 0 is 1, right? So let's take another one, say 10 to the power say 0.000001. Now you can see it's even closer to 0, and let's see what is the value, right? So let's take the calculator again. Right? 10 to the power x to the power y, say 0.0000001. Now it's 1.0000023 blah blah blah. Now you can see it's getting closer to 1. So when you make it more and more closer to the 0, that means you are making it smaller and smaller, but do not go beyond 0. It is getting closer and closer to the 1. So that is something you have to accept. That is a reality of numbers, right? That is a reality of numbers, right? So therefore, again, by looking at the pattern, no one can argue against that. No one can argue against that. You have to accept the fact that what? You have to accept the fact that yes, this is going to be 1. This is going to be 1. So that is something we have to understand or appreciate. Just like you appreciate to understand these two angles are the same, right? These two angles are the same. 5 plus 2 is 7. You have to appreciate that again, because that is the reality. By looking at the pattern, it happens. Therefore we have to say that yes, this is yes, right? So actually this is the informal way. X to the power 0 is 1, but in formal way you can say that we can say that uh, limit when x tend to 0, some constant to the power x is 1. It is getting close and close to the 1. Actually you have to check not only from this side, you have to check from this side also, like minus 10, minus 1, minus zero point 0.1. Like again you will see that it is getting close and close to the 1. It is getting close and close to the 1. Therefore we can say that this limit exists. So those are some limits. Now we are okay. Actually those are limits. You learn those things as just facts in your O level, right? So someone will say what is 10 to the power 0? Okay, you will say 1. That is I don't know whether you have check those values by looking at the patterns in your O level. They don't do that much, right? So they just say that 10 to the power any number to the power 0 is 1. But now you can see that yes, that is the nature of maths, that is the nature of numbers, right? Okay, so the next one is, right, next one is 0 to the power something is 0. That that is not a hard thing to understand, right? So we know that n to the power m means, so that again here you don't need a concept of limit, but here you need the concept of limit. For these two you need the concept of limit, right? Concept of limit. For other things you don't need the concept of limit, right? So that's conventional maths is going to do. But you can see that we found three places where we have to understand using the concept of limit, right? So gradually we are learning limit now. Okay, but here also you don't need, you know that n to the power m means n into, it's just a convention way of writing m times, right? M times. Of course 0 to the power x means 0 into 0 into 0 into x times, right? X times it's going to be 0, because nothing multiplied by nothing is going to be nothing, right? Nothing again, it's nothing multiplied by nothing is nothing, so the result is going to be 0. So that is something self-explanatory. But these three you have to understand using the limit. Of course you can see that in your school they have taught you this without explaining the limits, because at that time, because calculus is not in your syllabus, they just mention it, okay, x to the power 0 is 1. Okay, but actually you have learned your first limit in your O level without using the term limit. Okay, right. So now let's move on. So that is all about the actually we were thinking about the concept of 0. While we were discussing about the concept of 0, we gradually learn about the concept of infinity and also the concept of infinity, because these three we need the concept of limit. Okay, right. So let's move on. Now we are going to discuss about, so actually this is the 1 over x graph that we mentioned. You can say when x is reaching to 0 from positive side, it is getting bigger and bigger. That means it's getting more into plus infinity. But when you are reaching it from negative side, it is getting closer and closer to the minus infinity. So that is why we have like this, right? And of course you know that when this x, now this is rather than 0, it is x now. When this x is getting bigger and bigger, right, bigger and bigger, it is going to reach to 0. So that we are going to learn in our next topic, the concept of infinity. Anyway, while we were learning about the concept of 0, we learn about the concept of infinity little bit, but our main concern or the focus was on 0. Now let's focus on the infinity and try to understand everything about infinity, right? So once you know everything about 0, everything about infinity, then we are going to just generalize it to any limit. Then we will say that okay, we know the concept of limit. Okay, right. Now let's move on to the infinity, right? Right, concept of infinity. So infinity is a concept in maths, right? Concept in maths. Right? It's a concept. Again, I'm saying it's a concept, right? It's not a number, right? Just 0 is also not an actually number. Sometimes we call it number. It's a concept, right? It's a special concept. Nothing, right? Nothing is there. So similarly, concept of infinity means, so we can say it's not a number of infinity. It's not a number. Actually, 0, if you want, you can take it as a number, but infinity is not a number. It's a concept, right? So it represents the concept of endlessly very large, right? Very large, huge. How large? Endlessly large. So you can't quantify it. You can't quantify it. So then we use the we use to that concept we give a name and we call it infinity, right? Infinity. It's a mathematical concept. Okay, mathematical concept to represent a very large thing. Okay, right. Again, you have a sign for that also. If it is very large in positive way, we call it positive infinity, right? For example, I have a huge amount of money. I even don't know how much of it. Then I have a positive infinity of money. If I have a debt or if I have to pay someone very large amount of money, right? So that means how large even I don't know. It's extremely large, but I have to pay it back. That means it's negative infinity. So that is how those two, positive infinity and negative infinity, comes. So remember, I told that when it comes to 0, you can't say whether it's positive 0 or negative 0, but when it comes to infinity, definitely you have to say whether it's a positive infinity or negative infinity, right? Then someone will ask, you are telling that you can't have something called positive 0 or negative 0, right? Then you mentioned in the previous topic something like this, right? 0 plus and 0 minus. This is not positive 0 and negative 0, right? So this is different thing. This means you are reaching to the 0 from positive side. Here you are reaching to the 0 from negative side. So this is not positive 0, right? This is not positive 0. This is, if positive 0, I would write like this, right? This is, you are reaching to the 0 from positive side. You are reaching to the 0 from negative. Actually, not only the 0, you can reach into the 5 from positive side. You can reach to 5 from negative side, right? Negative side, sorry, just negative. Or you can reach to minus 5 from positive side. You can reach to minus 5 from negative side. So remember, this is your 0, this is your minus 5. If you reach from this side like minus 10, minus 6, minus 5.1, minus 5.01, minus 5.001, so that is minus 5, you are reaching it from negative side. But if you come from C 10, 0, minus 1, minus 4, minus 4.5, minus 4.9, minus 4.999, minus 4.99999, that is, you are reaching to minus 5 from positive side. So it's here negative and positive means basically that you are coming from the left side or you are coming from the right side, because right side has the positive values, left side has more and more negative values, right? So it's a different concept. Okay, right. So you have to collect those small concepts together, and then you put those everything into the context, all of a sudden you have calculus. Okay, right. Right, so let's move on to the concept of infinity. So it has a sign, of course. Infinity can have a sign, not can have, actually. Infinity has a sign. So positive infinity means endlessly very large positive value. Negative infinity means endlessly very large negative, or something you have to owe, or you have to pay, right? Right. So now similarly, just like we discussed the concept of the properties of 0, of course, in some cases infinity came. And now let's concentrate on the properties of infinity. Okay. Right. So remember, infinity is very large. It can be positive or it can be negative. Then we call it positive infinity and negative infinity. But here you can see I have not mentioned whether it's positive and negative in most of the cases. That means it's applicable to both positive and negative. It doesn't mean that this infinite does not have a sign. So if I have not mentioned whether positive or negative, it means it's applicable to both positive and negative, right? Both positive and negative. That is the idea. Okay, right. Uh, and of course, in some cases, I will specifically explain that. Okay, that is I'm referring to positive infinity, right? So if I have infinity, and if I add something, so remember k is a finite value, something like 10, 100. So when I say finite value, it can be minus value, positive value, 0, right? So again, you have to look at it seriously. When I say finite value, it can be a 0, it can be a negative value, it can be positive value. For example, 0 is a finite value, 5 is a finite value, minus 10 is a finite value, half is a finite value, 0.00000001 is a finite value, even a million is a finite value, billion is a finite value, trillion is a finite value, right? So then infinite means value which is infinitely large. So you can't say it's a trillion also, it's even bigger than trillion, right? So that is where the infinity comes, right? So finite value means it can be very large, but still it's finite, right? Trillion is a finite value. Okay, so the trillion to the power trillion is still a finite value, right? Okay, so that is how you understand, right? So let's take infinity. If you add a finite value, the result is again going to be infinity, right? For example, if I have infinity and if I add 10, it still is going to be infinity, right? So that you have to understand, right? So it's not going to uh, counter or contradict with any of your logical thinking. So if you feel like no, that is not logic, so I think that it is you are violating the beauty of logic, then of course let's discuss, right? Let's discuss. So what I am saying is, if I have infinitely large value, infinitely, if I add something to that, it's again infinity. Something like you have the sea, you are adding a water, bottle of water. It is not going to affect it. Still sea is the sea, right? If it is an infinitely negative thing, so you have to pay, right? Infinite number of debt is there, right? You have to pay billions, not even billions, not even trillions, a very very large amount, even you don't know how much it. Now someone gives you 100 rupees, okay, use this 100 rupees to pay your debt. Now still what you have to say, still my debt is infinity, right? Because it's not going to affect, right? So again you have to think, you have someone comes and give you trillion and asks you, okay, use this trillion to pay your debt. Still, if your debt is negative infinity, still it is negative infinity, right? So that is something you have to understand, because infinity means very 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 large value. It is not even in trillion. Okay, so if it is positive infinity, if you add something, still it is positive infinity. If it is negative infinity, if you add something finite value, still it is negative infinity. Okay, so then if I multiply infinity by a number, of course, if it is a positive infinity and if I am multiplying it by a positive number, still it is going to be infinity, right? So it's something like a million multiplied by 10 is 10 million. It's getting bigger, right? Again, if you multiply it by half fraction, it can be a little bit smaller, but still infinity is infinity, right? Infinity is infinity. For example, if you have trillion and multiply it by half, it's going to be half a trillion. Of course, infinity is not like a trillion. If you half it, still it is infinity, right? It's still it is infinity. Of course, if you multiply it by a negative number, then sign is going to be changed. If you had plus infinity, now if you multiply it by minus 10, all of a sudden it's going to be minus infinity. Okay, if it is minus infinity and if you multiply it by a negative number, all of a sudden it's going to be positive infinity, and it's going to change the sign. It's going to change the sign when you multiply. So I did mention here the subtraction. If you subtract a value from infinity also, it's going to be infinity. Actually I forget to add that. There should be another entry here. Infinity minus k is also infinity, right? If it is negative infinity, the result is negative infinity. If it is positive infinity, the result is positive infinity. Okay, right? So then next thing, if I add two infinities together, that means I have positive infinity, I am adding another positive infinity, the result is going to be infinity. So that is common sense, right? So I have huge uh, money. So another person gives me another huge money. Yes, still I have huge money, right? Because infinite money I had, I got another infinite value. So it is not going to say do the difference to my concept of infinity, it's still infinity, right? So if you multiply infinity by infinity, it's going to be infinity again, right? So again you have to think, right? Million multiplied by million is million to the power million into million, so it's even bigger than million, so it's going to be increased further, right? Again further. But what you have to remember is, if one of these infinity is negative, then the result is going to be negative infinity. If both are negative, because remember infinity has a sign, only thing is zero don't have sign, does not have sign. If you have minus infinity multiplied by minus infinity, now we are saying it's positive infinity, right? So remember infinity has a sign, right? Right. So far we have understand these things without actually using the concept of limits, but actually whenever we are saying infinity, we are talking about limits, right? Because it's limit to a value. But sometimes infinity you can understand without the concept of limit as well, right? But this is where you really seriously again you have to think like using limits, right? So this one, of course it limit. Whenever we say infinity, it is all about limit, because there is no number called limit. But when it comes to this one, a number divided by infinity is zero, again you have to go by the limits, right? So again let's get back to our examples. Let's see something like this, right? So it's more than, rather than 1 divided by infinity, I could have mentioned it as k divided by infinity. Anyway, k divided by infinity. So let's say that take that k as something like 10. So let's take 10 divided by 10. That is 1. Right. So let's start with 10 divided by 100. And that is half. Right. So now I'm making it bigger and bigger, because ultimately I want to reach it to infinity, right? I want to reach it to infinity. So this number I can take 10 or 5 or whatever. Okay, so let's say 10. I'm making it bigger now. 10 divided by 100, and that is 1/10. 1/10 means 0.1. Right? 10 divided by 1000, that is 0.01. So that is even closer, even smaller than this one, right? So likewise, if I have very big number 0.0000 blah blah blah, it is going to be 0.00001. So you can see it's getting small and smaller, small and smaller. So ultimately we will say, when this number is reach into infinitely bigger value, this number is getting closer and closer to zero, because you can see this is 1 billionth or maybe 1 trillionth away from zero, right? So likewise, now we can say that again using the limit k divided by x, when x tend to infinity, this value is 0. This value is 0. So that is another limit that you have learned, right? So earlier we discussed that limit when x reach into 0, k divided by x is infinity. Of course, if it is positive, positive infinity, and negative, negative infinity. So now you can see two limits you have already learned, right? So this one, this one. So that is, so those things you have to remember now. Actually you don't have to memorize. You will see that those are common sense, those are common sense, right? So something divided by 0, infinity, something divided by infinity, it's getting closer and closer to 0, right? Closer and closer to 0. So that is how we got this one, something divided by infinity 0. Earlier we got something divided by 0, infinity, and something divided by 0, infinity. Of course it can be positive infinity or negative infinity, depending on the sign, depending on the sign. Okay, right? So now we are gradually building the knowledge of limits actually. Okay, limits. Again, if you are dividing it by positive number, uh, again is going to be getting closer and closer to 0 in positive side. If you are dividing by very bigger and bigger negative number, again it's going to getting closer and closer to 0, but from the negative side, right? Still it's not plus 0 or minus 0, it's 0, because this side also you are getting closer and closer to 0, from this side also you are getting closer and closer to 0. Now you can see here you have only one thing, there's nothing called it's 1 over plus infinity is plus 0 and 1 over negative infinity. No, that is nothing like that. If 1 over infinity, whether it's positive or negative, it's 0. Okay, but in earlier case what happens is, so again you have to pay attention to those small things, right? So that is all about professionals, right? So here of course there are two things, right? So actually another reason why you are learning this maths is, of course, we want to make sure that you can handle conceptual things, abstract things, and of course you can handle complex things, and of course you pay attention to details, right? So as a professionals, we want to have people who can pay attention to details. So that is how the doctors, engineers, of course software engineering is part of engineering, accountant, so these are serious people. They don't just look at things, right? They look at things in a very serious manner. They look at those tiny things and analyze those things. So that is what you have to do. If you have that mindset, professional mindset, of course you are going to do maths. If you don't have that professional mindset, you are going to fail maths. That means yes, that is good. Otherwise you are going to end up as a person who are expected to do serious things like a doctor, engineer, accountant. No, you don't have that attitude. Please do something else. Please do something else. If you want to be a professional, yes, pay attention to things, right? Pay attention to things, analyze things, identify patterns, right? So that is why in higher studies we don't care whether you pass or fail the exam, right? Of course we like if you pass your exams, but we don't care just because you are not good enough to come into that profession you have failed, right? You don't have that seriousness, right? You don't have that attention. Okay, so those who have that, we are helping you, right? So those who have that attitude and attention, we are helping you, yes, to become a person who can take that kind of responsibilities. Okay, right. Right. So now you can see that now we have understood the concept of zero. We have understood the concept of infinity. Right. Now we are going to discuss about things which are indeterminate. Right. So that means these things, by looking at the pattern, we can determine. We can determine. Right. We can say that infinity plus infinity is infinity. Right. Infinity plus something is infinity. Even things like this, something divided by infinitely large value is getting closer and closer to 0. We can, using the either the common sense or pattern, we can tackle these things. But mathematicians found that there are scenarios, if you find that these things are interesting, the other scenarios are going to be even more interesting and even more challenging. So they found that there are scenarios you can't determine, right? So it's a helpless situation for mathematicians, right? So what are those scenarios? Of course we know how to number divided by infinity, number divided by 0, those things we can determine. So these things you can't determine. So here you can see 1 2 3 4 5 6 7 scenarios where mathematicians found that no, we can't figure it out what is going to happen there. So what are those scenarios? 0 divided by 0, infinity divided by infinity, 0 multiplied by infinity, infinity minus infinity, 0 to the power 0, 1 to the power infinity, infinity to the power 0. Right? Of course, the moment you look at this, right, if you are new to calculus, some of you might feel okay, I feel like I don't have any issue with the second one or third one or fifth one. Of course I feel like weird, I'm also not very sure how to calculate this particular value, but this one I think like I feel like I can do it. So I just ask you to look at 1 2 3 4 5 6 7, right? So I will just label it. Which one you feel no, it looks okay, I can logically determine what is that value, right? So what is that value, which one you feel like easy to figure it out, which one you feel like yes, these are really weird concepts, right? So let's call it A B C D E F G. So which one you feel like not really weird. No, I think I can give a reasonable guess to that value. So I ask you to put it into the chat, right? So not weird things. You feel like, no, I can tell exactly the value. Of course, you can't tell in any cases, but you feel like your gut feeling says, I can give a reasonable answer to that. Which one you feel like you can give a reasonable answer to that? 0 divided by 0? If so, you have to say A. You can have multiple answers also. If you see like, okay, 0 divided by 0, I feel like 1. So then you can just say, okay, I feel like A is a reasonable answer I can give. Infinity divided by infinity, 0 multiplied by infinity. If you feel like you can give a value, just put it into the chat, right? So likewise, you can say something like B and D, C and E, right? So of course, all of your answers are wrong, right? So that's okay, but I just need your gut feeling. I just need your gut feeling. Which one you feel like I can give a reasonable answer? So just put it into the chat. I like to see whether you are getting common set of things, whether most of the students say something like E, or most of the students says A, no one is saying G, something like that, right? So 0 divided by 0, infinity divided by infinity, 0 multiplied by infinity, infinity minus infinity. So if you feel like infinity minus infinity is 0, you can just say D, right? 0 to the power 0, if you feel like 0 to the power 0 is 100, you can just put it, or 0 to the power 0 is 0, you can just put it like this. Or 1 to the power infinity means what? 1 into 1 into 1 into 1 into whatever, infinite, go, right? So go like this, infinity, right? So you know that 1 into 1 is 1, that into 1 is 1, right? So likewise, so which one you feel like I can actually guess. I may be wrong because you are saying that those are indeterminate, but I feel like I can give reasonable value. So can someone put it into chat? No one? Yes. So a lot of people saying C, right? So some people say C is a I can give a reasonable answer. So they are saying that I can give a reasonable answer to C. I hope your reasonable answer is what? Hopefully, I think what you are thinking is 0 into infinity is 0, because regardless of how big that number is, if you multiply it by 0, you feel like it's going to be 0, right? It's going to be 0, but mathematicians found that that is not the case. Now those things are called counterintuitive things. So for me, I feel like initially, without knowing the calculus, I also thought that this is going to be 0. And of course, this is somewhat debatable, but again, someone feel like, okay, if you have very big infinite amount of things, you are reducing infinite amount of things, it's again going to be 0. But that is not the case, right? Of course, this is something weird, so you can see it's a very scary thing to do, but sometimes you will say, since it is 0, it is going to be 0. Again, no. So this is again 1 into 1 is 1, that into 1 is 1. You can see, look at the pattern also. The pattern says, right, it's going to be 1, but again not the case, right? Your gut feeling says 1, but reality is that is not 1, right? So this one also is a very weird thing, right? So you don't want to look at this, right? You don't want to look at this, you don't want to look at this, but sometimes for these four you want to give reasonable guess, but none of these guesses are going to work, right? None of these guesses are going to work. Then you will see that, you will ask that, okay, are we going to find that value? Are we going to get a value like 10 or some special number? No, we are not going to get a special number for any of these things, right? So that is another thing. We are not going to calculate and say that 0 divided by 0 is this much. No, we are not going to do that. It depends on your function, right? It depends on your function. Sometimes you will get the 0 divided by 0 as 100. Sometimes you will get it as 0. Sometimes you might get it as infinity, right? So we don't know exactly the value unless we analyze the exact functions you are doing. Of course, when for function A, when it results in 0 divided by 0, using the concept of limits, we will find that the actual value is 100. In other functions, row A, you get it 0 divided by 0, but using the calculus, you will find that actually this value is not 100, actually the value is 0, right? So that is what we are going to do using the concept of limit. Okay, so this here we are not going to find the values of these things, but what we have to know is these things are cannot be determined using conventional maths, but yes, we are going to find a way using the concept of calculus. Okay, right. So you have to remember these scenarios: 0 divided by 0, infinity divided by infinity, 0 into infinity, infinity minus infinity, 0 to the power 0, 1 to the power infinity, infinity to the power 0. So what we know is, though it looks weird, we know that something divided by 0, of course, is the limit, is infinity, right? Of course, positive or negative depending on the whether you are going from positive side or negative side. Again, something divided by infinity, or when this is getting bigger and bigger, this is getting closer and closer to 0. So those things we know by looking at the pattern, right? Then of course, something to the power 0 is 1, right? Something to the power 0 is 1, right? So that is another thing we have understood. So those are three limits that we have already understood, right, using limits, right, by looking at the pattern. But these things we are going to look at it in a different way. Again, we are going to look at the pattern, but here you can say 1 divided by 0 is infinity, 1 divided by infinity is 0, n to the power 0 is 1. There is a specific value, right? But as I told you, here there are no specific values. That value depends on the situation. So that is why we have taken this separately from these three, because here we have values, the value or concept, but here the result is going to be depends on the actual scenario you are thinking, looking at. So that is why we have taken it. So these things are related, but these things, here we have always we get into this results in this concept or value, but here the result is going to be depends on the your actual function. Okay, so that is why we have separate these three from this set. Okay, right. So let's move on. Right, so now we are going to discuss about the concept of limit. Using the concept of limit, we will be able to figure it out how to calculate these values as well. Okay, so mathematicians, they never, right, fear of things, right? So they never get things, throw it out and say they just try out. So the people like Leibniz, Newton, they came up with the concept of limit to calculate those values as well, and they found the values. Okay, right. So let's see what is mean by the concept of limit. Okay, now actually we are moving to the concept of limit. Assume that we have function like this. We have function like this. When we want to find the value at this particular value a, right? So let's say we want to find the value at this particular place a. What is this value is, right? Of course we can find that value if when we are reaching from this side, each reach to a particular value. When you are reaching from the other side, that is positive side, it each reach into a value, right? Now we can see from when it comes here, it is here. When it's here, that means you are now getting closer, it is here. When it's somewhere here, it's getting closer to the, right, from this side, it is getting closer to this. Now we can see it is reach into this L value, right? Now we can write it like this. So this is how you write it is limit. So I'm talking about this side, this side, limit x tend to a from positive side, so that means from right side, this fx. So assume that this is fx, this fx is reach into L, but since we are using the concept notation limit, we can just say equal to L, right? So when it is getting closer and closer to the a from this side, it is getting closer and closer to the L, right? So the other side, so that is we are coming from this side, we can say that limit x tend to or reach to a from negative side, fx, again if it is reach into L, if it is reach into L, right? So we say that there are three conditions. So let's move on to the three conditions now, right? So if you have any questions, then and there you have to ask, right? So assume that when we are reaching to A from negative side, it is reaching to the L. So that is exactly what is happening here, right? So when you are reaching from here, it is getting closer and closer to the L. Also, when you are reaching to the A from positive side, again the value is reaching to L, right? Again the value is reaching to L. That is, we are having something like this when you reach from there. So earlier case is when you reach from there, it's getting closer and closer to the L, right? So if this happens that both are the same L value, so those are the two conditions. The third condition is also there. uh, right? If both are reaching to the same value, and if that value exists, or if both are reaching to the same value, we say that, now forget about the negative or positive side, we say that when x is reach into a, fx, the limit of fx is L, right? So this happens when only when what, when you reach from here also it is reaching to the L. When you reach from here, from left side also it is reaching to the same L. In that case we say that this limit exists. This limit exists. Okay. So there can be a situation where limit does not exist. So let's take an example for that. Right. Let's take an example for that. For example, assume that I have scenario like this. So I will just draw a small graph. So I have graph like this. At this point, it goes like this, right? So you can see, now when I reach in from here to this particular value, it is getting closer and closer to what, this L1 value, right? But when I reach from this side to the same A, it is getting closer and closer to the another value, let's call it L2. Now you can see L1 and L2 are different, right? So let's assume this is fx, right? Assume this is fx. Now you can see limit x tend to a from negative side, fx is L1, right? Because it's getting closer and closer to L1, right? When I come, right, you can see here. But when I say limit x is reaching to a, now from positive side, it is not L1, it is L2. In that kind of a situation, we say that there is no limit here. There is no limit here. Of course, there is a limit here, negative limit, positive limit, but you can't write something like this now. You can't say limit x tend to a fx is not determined. So that is not available, right? Why? These two are reached into two different values, L1 and L2. In that case, we say that there is no limit at the A. But situation like this, of course, when you move from here also it is reaching to the same L value. From when you reach from right hand side also it is reaching to the same L value. In that kind of situation, yes, this exists. But this kind of situation, of course, situation like this limit exists. Situation like this limit exists. Only in this particular place there is no limit. There is only no limit. So that is how you understand it. If you have a limit, when you coming from both left hand side or right hand side, you must reach to the same value. Then only we say that there is a limit. Otherwise, you have the partial limits from left limit and right limit, but you don't have full limit. You can't just you can have this and this, but you can't have something like this, right? Because from left side it is reaching to another one value, from right side it is reaching to another value. Okay, right? So you can't say that these things are difficult, right? So these things are extremely simple things, right? Extremely simple things, right? If you have the patience. Okay, right. Right. So you can see the limit extend to a fx equal L if and only if this left side limit and the right side limit has the same L value, right? If this is L1 and L2, we say that this is not L, or this does not exist. Okay, right. So there are situations like that. You can find the limits like that. So let's take an example. So let's take this as a function, 2x squared minus 2 divided by x minus 1. Of course, you can assign values and find out what is the value. For example, if you have 5 here, 2 into 25 minus 2 some value, 5 minus 1 some value, you will get the value, right? But in this case you can see there's a special number which results in 0 divided by 0, right? 0 divided by 0, you can see that 0 divided by 0 we never know. That is when x is 1. So when x is 1, obviously 1 divided by 1 is 0. Here 1 squared is 1. 1 into 2 is 2. 2 minus 2 is 0. Now it's 0 divided by 0. Right. So as I told you, we don't know what is the value of 0 divided by 0. Right. What is 0 divided by 0? Therefore what we have to do is we try to reach 1 from left side and also from right side. Right. So reach 1. Sorry, reach 1. So let's start from, so what we are going to do is uh, so I don't know what is this fx is, right? Some weird thing, but at 1 I want to check what is going to happen. I don't know still whether this shape is something like this or something like this, something like this. If it is something like this, there is no limit. If it is something like this, there's a limit. So we are going to check whether is it something like this or something like this. Something like this means when I come from this side also it is reaching to the same value. When I come from this way also it is reaching to the same value. But if it is something like this, we are going to reach to two different values, right? So two different values. Now what we are going to do is we are going to assign some values and we are going to make it closer and closer to the 1. So let's put 0.5. So you can take a calculator and do that. 0.5 squared into 2 minus 2, you will get 3. Now we want to make it closer and closer. Now which side we are going from here? From 0.5, 0.9. So that means we are coming from this side, right? Sorry, not from this side. Sorry, other side. Right? 0.5, 0.9, 0.99, 0.999. You can see that is this side. Right? So this is this side. So this table is coming from negative side. Right. But here what we do is we are starting from 1.5, 1.1, 1.01, 1.001. You can see here we are coming from this side, right? So, okay, so let's put 0.5. You will get, if you do the calculation using calculator, 3, 3. 0.9, 3.8. 0.99, 3.98. So likewise 0.9999, 3.99998. So you can see it's getting close and close to what? You can see it's getting closer and closer to the 4. We can't say it's 4, but it's getting closer and closer to the 4. If you do the same thing from the other side, like 1.5, 1.1, 1.01, 1.001, you can see that you have to do that using calculator. It's again getting closer and closer to the 4. Now we can see from left side also it is getting closer and closer to the 4. Right side also it's getting closer and closer to 4. Of course, therefore it is this kind of situation, not this kind of situation. Therefore we can say that limit, let's take it as fx when x is reached into 1, in this case is 4, right? So you can do that only when both from left side and right side you are reach into a particular same value, right? You can see it is getting closer and closer to 4. It's getting increase and getting closer and closer to 4. It is getting decrease and getting closer and closer to 4, right? It's decreasing, right? So this is smaller than this, even next one is smaller than this. That means it's getting closer and closer to 4. So that is where how you find the limit. Of course, without a technique, here we just use a raw concept of limit, right? Raw concept of limit. Okay, right. So now let's see, can we find that without doing this substitution? If it is there, that is good, because this is time consuming thing. This is time consuming thing. Actually, that is what the mathematicians did. They did this and found that okay, it is getting closer and closer to 4, right? So therefore it must be 4, right? But if I just substitute it, it is 0 divided by 0. Is there a way to find this value 4 using a maths? Yes, that concept is the calculus or the concept of limit. Okay, right. So that then they develop some techniques to straight away find that value 4, right? That value 4 without doing these calculations. So that is good, and that is good, right? Okay. Right, so let's move on to the what are those techniques available, right? What are those techniques available? So just 1 minute, I'm running out of battery. Just 1 minute. Okay, right. So let's see what are those techniques, because we don't want to do like this. Of course we can do like this, but it will take a lot of time. What are the techniques available to do that, right? Right. So mathematicians from Newton's time, so they came up with some theorem. So they look at those uh, patterns and they just formulate those as theorems. Okay. So all of these theorems you can understand. Don't think that because of its huge notations, so don't get scared. Each and every one you can understand, right? How to understand? Take some examples, look at the patterns, you will see, okay, that is correct. So that is something the mathematicians have so, right? So just like f equal ma, right? Just like pv equals c, similar thing. So you can see when it comes to calculus, it is something like science, right? So we look at the pattern and find the formula, right? It's not purely from the of course it's logical, but you have to look at the pattern and understand the concept. Okay, right. First one says, so let's write it down. Right. First one says limit, right? So I will write it down. Okay. Limit x tend to a fx equals c if fx is a c. That means something like this. This fx is a constant function, right? So constant function means what? This value is always c. So though you change x, the y is always c, right? So that means something like this. It's some sorry. So let's delete this. So you have something like this. It's always c. It's always c. It's a constant function. So your fx is c, right? So when it is 0 it is c, right? When it is 1 it is c, 2 c, it goes from negative minus infinity to the positive infinity, it is c. So then it says when you have some value called a, right? When you have value called a, if you want to find the limit value at x equal a, it says it is going to be c. So that is common sense, right? So that is also c, because everywhere it is c. If everywhere it is c from minus infinity to plus infinity, for particular value a, it's going to be c. So that is common sense, right? That is common sense, right? So if it is everywhere 10 10 10 10 10 10 10, if I take a random time and check, it's going to be 10. So that is the first limit you have to understand. So you can see nothing. You will say that why you are telling like that? That is common sense. Of course, yes. That is why you are saying calculus is something you can easily understand, right? Right. So that is obvious thing. If you have constant function for any a, the limit value is also going to be c. Actually, here you don't need limit. You can just substitute, right? Oh, right. So that is another thing. There are situations where you can just substitute and find the value also, right? So substitute means if you have something like that is another thing I want to explain first, right? So I'm taking a lot of time uh, because the subject is very easy. Only thing is, you if you don't get those concepts first, you are in trouble. So something like this, let's assume that I have, say this is y equal x plus 1, y equal x plus 1. Now you know that when x equal 1, the y value is what? 1 plus 1 is 2. 1 plus 1 is 2. So that we say that if it is fx, let's call it fx, right? So I can say that f1 equal 1 plus 1, which is 2. Right? So similarly, if I want f2, that is 2 plus 1, that is 3. Right? So that's something you know under in your O level and relations and function subject in your semester 2, something you know. Then what is the meaning of limit x tend to 1 fx? Is it same as, right? Is it same as f1? Right, now we can see this one is f1. This is when x is reach into 1 fx. Are those two the same or different? Are those two the same or different? Of course, in situation like this, both are the same, because when you try to reach from one from left side to the right side, still we are going to get close and close to what? 2, and it is going to be same as f1. But there are situations these two are not the same, so these two are two different values, or sometimes this you can't calculate, this you can calculate, right? You can see that in 99%, 99.9999% of the time, these two are the same, these two are the same, right? So that is, when you ask to find the limit of a value, you can just substitute and find the value, right? So that is something you have to understand. But there are very rare situations, this one you can't calculate, because you are getting something like divide 0 divided by 0, infinite divided by infinity, infinity minus infinity, when you do like this. But using limit you get the value. So that is so that in those kind of situation we can't do this to find this. But if that is not the case, when you ask to do this, what you have to do, you just do this, you just do this and you get the answer. Okay, so that is something you have to first understand. Okay, right, so let's take that kind of example. Right, so you can see, so you have asked to find limit of 2x plus 3 when x is reached into 1, right? So what you have to do is, first just see whether that is, as I told you, 99% 9999999 of the time the limit and the value is the same. So therefore you just check whether, just substitute and see whether you are not reaching to any of these conflicting situation. What are those conflicting situation? 0 divided by 0, infinity divided by infinity, 0 minus 0 into infinity, infinity minus infinity, 1 to the power infinity. If it is not the case, you just substitute and do it, right. So you can see, if you just substitute x equal 1, 2 into 1 is 2, 2 plus 3 is 5, answer is 5. So you can see, if you are given, if they give you a limit question, and if it is just a normal value you are getting, no conflicting thing, you just substitute and do it, right? You just substitute and do it, right? So this is another example. So here you can see, when x equal 3, 3 to the power, it's 3 to the power, right? So it's going to be 3 to the power 2 plus 5 into 3 divided by 3 plus 9. So that means 9 plus 15 divided by 12. So you will get the answer as 2, right? 2, this is 24 divided by 12, right? 24 divided by 12, 24 divided by 12, answer is 2. So that's it, right? So you don't have to do limits, actually you don't have to do limits in that case. But in between, in one of the steps, you, if you get something like 0 divided by 0, now you are in trouble, now you are in trouble. Or infinity divided by infinity, or 0 to the power 0, or infinity minus infinity, or 0 into infinity. Now you can't just substitute, you have to come back to the concept of limits and do it in a proper way, right? So that is something you have to learn at the upfront, because most of the time if you take a graph, it's the limit exists, right? Limit exists in normal way. But there are situations you can't do like that, you have to use some concepts, or either you have to do a table and find what is it reaching, or you have to use the concept of limits, right? These concepts are there when you don't find that value straight away, then you can use these concepts. Okay, so of course the first one is, of course you don't have to use this concept, that this concept just confirm that you can just use your gut feeling. Okay, so if it is a constant function, for any limit, it's going to be that particular value. Okay, right. So then if you have a function fx multiplied by c, if there is a limit for fx at a, you can just take the c out and find the limit value and multiply. Similarly, if you want to add, you can take the separate limits and add them together. If you have subtraction, you can take the separate limits and subtract. If you have multiplication, you can take the separate limits and multiply. If it is a division, you can take the separate limits and divide. If it is a square root or any root, you can just take the limit of the original value and take that rule. So those are common sense sort of a things, right? Common sense sort of a things. It's something like this, right? Something like this. So let's take one example. uh, so the thing is, sometimes you don't take these things seriously, right? And sometimes you don't understand, okay, this is correct. Of course you can understand this is correct, right? So let's take something like this. So I have something called fx, which is x, then I have gx, which is 2, right, which is 2. Now what is the limit of limit, okay, forget about the limit. What is the f2? Of course the f2 is 2 because fx is x. What is g2? Because gx is always 2, it is 2. Then someone will ask, what is I have, if I have function called fg and let's say hx is, that is what you learn in your semester 2, right? Relations and function, fx plus gx. Of course fx plus gx is what? X plus 2 function, that is hx. Then if someone asks, what is h2? You know that h2 is 2 plus 2, which is 4, which is same as, of course h2 you can straight away calculate from this one. 2 plus 2 is 4, or you can say that h2 is same as, because hx is fx plus gx, that is f2 plus g2, right? F2 is 2, g2 is 2. Therefore you can see, either you can substitute it to this hx function, or you can separately find f2 and g2 and add it, right? Add it. So that is something you do, right, which is very common, straightforward things, right? So but now you don't memorize it, right? So you just do it because you know it's correct. So what this theorem says is, it can be used for limits as well. It can be used for limit as well. So you take this limit, you take this limit and add those together, which is same as taking the limit for this particular value at 2, right? So you can see that concept can be extended to limits as well, limits as well. So addition, subtraction, multiplication, division and roots. Okay, right. So let's look at some examples now. So here you can see, when I was asked to calculate the limit of 2x plus 3 when x reached to 2, now I am using this concept. So I can separately take the limits and add the sum the limits. So therefore I am doing this limit, I am doing this limit. Of course if it's a constant function, the limit is also that value. Here I am taking the constant out, right? So because here you can see I can take the constant out. So now its limit of x, when x tend to 1, x, so it's always, you know that when x is reaching to 1, x is what? You just substitute. If you, when you substitute, if you are not getting 0 divided by 0, infinity divided by infinity, etc., that is the value. That is the value, right? So therefore this is 1, 2 into 1 plus 3. So the answer is 3 plus 2 is 5. Of course that is what I told. You can just do it, but we are just explaining that these theorems are correct. These theorems are correct. Okay, right? So if you have something like this, now we are using the division. So this function is division of this one divided by this one. Therefore I am applying the limit separately. I am applying the limit to this one and this one, because this is, I take this as fx divided by gx, then I can separate the limit to two of those things. So I am using this this rule, this rule. Okay, so after some time you will unconsciously use these rules, okay, just like to do like here. Okay, but remember that these things are valid, right? So then what I do is I am applying the summation rule, and also I am taking the constant is also out. Then you know that this is 3 to the power 2, then this is 5 to the power 3, because there are no indeterminate forms here. You happily get the 2. Of course you could have just substitute here and get it also, but this is just to demonstrate that you can use the concept of limit. You can use these rules. Those rules are perfectly okay. These rules are perfectly okay. Okay, right. Right, now we are going to discuss about the continuity. right? Continuity. So I am going little bit more than your exams. My target is not to make you pass the exam. My target is to teach you calculus, because I know that knowing Java or knowing database is not going to make you a good, smart, competent software engineer, right? So there are so many students in final year also, they don't have that mindset to do a software, developing a software. Of course, some of the students have the attitude issues. Some of the students, they can't understand these things in an abstract way, complex way. When it comes to real world software development, they can't tackle it. So I am trying to help you come into that point, right? So don't take these things as serious things. So that is why every time engineers are taught maths, right? So help them understand tackling complex things, right? Conceptual things, right? Then operating system, weird database, complex database, you will find that okay, that is not a big thing, right? That is not a big thing. Of course, rest of the people in the society feel like it's a very complex things, but engineers don't fear it, right? So they know how to tackle the complexity because they have worked with those complex things all previously in their studies, like maths, like infinity, zero, continuity, differentiation, integration. Then this code is just a nothing, just a nothing. So that is how you build your confidence. Okay, right? So let's move on to the continuity concept of continuity. So continuity means, as I told you, it's the same name suggests. So now I can say that at this point it is continuous, right? You can see it's continue, right? Again, if you take this, I can say at this point it is continuous. But there can be a situation something like this, and it goes like this. Now you can say at this point it is not continuous. So something like this, then it goes like this. It is not continuous, right? It is not continuous at this point, at these 2 points, and in this range. And again there can be a situation something like this, and all of a sudden it goes like this, again not continuous, right? You can see there is a gap. Whenever there is a gap, it is not continuous. If there is no gap, then we say it's not, it is continuous in that particular range. Okay, okay, so that is, again you can see, okay, nothing. Of course, that is why I'm saying calculus is nothing. ඕක කියන්න දෙයක්ද කියලා අයෝ. හරි. ඕක කියන්න දෙයක් නැති දේවල් තමයි calculus වල ඉගෙන ගන්න. හැබැයි ඊට පස්සේ කියලා කියනවා මට calculus තේරෙන්නේ නැහැ කියලා. හරි. ඔයාලට calculus තේරෙන්නේ නැහැ කියනවා. ඔයාලට මේ පොඩි පොඩි කතන්දරවත් තේරෙන්නේ නැති බොහොම ලදරු බාලාංශ මේ ලදරුවෙක් තමයි. හරි. So how to define it in a proper way, right? Of course, this is how we define it. First of all, if you want to see whether at x equal a, at x equal a, whether it's continuous or not, actually here it has to be a. First, this fa must be defined. fa කියන value එක තියෙන්න ඕන, right? So first, that is the first one. Then at x equal a, this limit must exist. So limit must exist means when you reach from this side as well as this side, you are getting close and close to the same value. The third condition is that limit value and the value when you get it from the substitute in the value must be the same. In that case, we say it is continuous. So there are three conditions you want to satisfy, right? So fx naught or fa must be defined. Fa, when the limit of a must exist, those two must be the same. Those two must be the same. So then we say that it is continuous at this point. At this point, okay, right? So now let's see what are the possible discontinuities, right? What are the possible discontinuities, right? So this is now, once you understand these things, you will understand the things better, right? Reality ලෝකේ තියෙන දේවල් වලට හොඳට තේරෙන්න පටන් ගන්නවා, හරි? Right, so this is a possible discontinuity. Now you can see it goes like this, then all of a sudden it goes to this point and goes like that, right? So now which condition is violated out of this? Of course, fx naught is defined. You can see fa is what? This particular value. So that is okay. So I will just mark which condition is not defined, satisfied. So this condition is okay. Limit extend to x naught fx exists. That means what? When you coming from the left and right, it must reach to the same value. Now that is violated. You can see when we reach from here, it is reaching to this value. When I reach to the a from this side, it is always this value. Now you can see these two values are different. So these two values are different means what? This is violated, right? If there's a limit, both must reach to the same value. Now from left side it is reaching to this value, from right side it is reaching to this value when I reach to a, right, when I reach to a. So therefore this is not satisfied. Then of course this is not continuous. This is, all three has to be satisfied, right, all three has to be satisfied. now මේ පොඩි දෙකේ පන්ති ළමයට නම් තේරෙන දෙකේ පන්ති ළමයට මේ කියවන දෙකේ පන්ති ළමයට කියන ඕව මේක මෙයා මේ අර limit කියන concept එක violate කරලා, හරි, limit කියන concept එක violate කරලා. So let's look at the limit concept of limit again. Right, so the concept of limit says, remember those are two things, limit, continuous. Now concept of limit says from you, when you're coming from negative side it must reach to the value, when you're coming from positive side it must reach to the value, and if both are the same only the limit exists, right, if both are the same only limit exists. So here it is, we are talking about the continuity which is related to limits. The first it says first the limit must exist, right, first the limit must exist, right. So in this case limit is not existing. Why? They are reaching to two different values. So what about this? Now when you reach from negative side it is getting closer and closer to this value, right. So let's draw it. It's getting closer and closer to this value. When you are coming from positive side again it is getting closer and closer to this value. That means what? That means obviously the limit exists. So therefore this is satisfied, right, this is satisfied, limit exists. Then it says you want to have fx not defined. Fx not defined means when you have x equal x naught or when you have x equal a, that value must be defined by your function. But you can see here there's a hole, that means it has not defined fa. If there's a fa value it has to, you must have value like that, right. So there's no value like that, there's a hole here. Of course the limit exists but fx naught does not exist, so it is not defined, right. So in this case because it says it's a hole, so that means definitely this is not continuous. So of course the limit exists but not continuous, right. You can see limit and continuity are two related things. There are situations limit exists but not continuous, right, not continuous, right. Okay, so now here you can see it is limit exists because from left side also it is reaching to this value, from right side also it is reaching to this value, therefore limit exists but fa is not defined. You can see there's a hole, therefore it is not continuous at this point, it is not continuous at this point. Okay, right. So let's move to another example, right. So let's look at the next one. Now you can see when we are reaching to the a from this side it is getting bigger and bigger, it is getting close and close to the plus infinity. When we are reaching a from negative side or the positive side or the right hand side it is getting bigger and bigger in negative sense. So now you can see when it is reaching the a from left side it is reaching to the positive infinity. When you are coming from the right side it is reaching to the negative infinity. That means the limit does not exist. If there's a limit exists, right, so if it has to reach to the same value, but here positive infinity and negative infinity are two different values. Therefore we say that, now this is how you write it. If this is fx, this is fx, we say that limit x tend to a fx, if it is coming from negative side or the left side it is plus infinity. When limit x reaching from a from positive side fx is, now you can see it is going to the negative infinity, right, negative infinity, that is negative infinity. Now these two are two different, therefore the limit does not exist. Therefore I can write this, but I can't write something like this, limit x tend to a, that is either negative or positive side. What is fx? I don't have value because from negative side left side it goes to plus infinity, from right side it goes to negative infinity, therefore this value does not exist. That means limit does not exist. Of course if the limit does not exist it is not continuous, obviously it is not continuous. Continuous නෑ කියලා මෙහෙන් ගිහලා මෙහෙන් මතුවේ, හරි. So that is another example where the limit does not exist, therefore it is not continuous, right? So this is another example, right? This is another example where when you reach from left hand side, it is moving to the negative infinity. When you are coming from the right hand side, it is reach into the negative infinity. Now is it limit exists now? Limit exists. Yes, limit exists. Why? From left hand side also it is negative infinity. From right hand side also negative infinity. Therefore, now for this one, this is satisfied. Right? The limit exists. The limit exists and the limit value is negative infinity. But unfortunately, now fx node does not define. Right? This is not defined. Why? Though limit exists, right? Now the limit exists, but if I just substitute the value, you are not going to get a value because it's only a limit, right? Not a value. Not a value. We can just make it closer and closer to a and see what is the trend from left side. We can make it closer and closer to the a from right hand side and see what is the value. But if I just substitute the value a, it is going to get something like 0 divided by 0, infinity divided by infinity, or something like that, some weird scenario, right? Right. So therefore here also it is not continuous. Why? The limit exists, but the value is not defined at this particular point. Value is not defined in this particular point. Therefore we say here also it is discontinuous, right? Here also discontinuous. So you can see that there can be situations limit exists, right? Here you can see limit exists, here no limit exists, here limit exists, here limit does not exist because but here limit exists but not continuous, right? Not continuous. Here limit does not exist and not continuous. Limit does not exist and not continuous, right? So what we have to understand is if it is continuous, always limit exists, but limit exists doesn't means it is continuous, right? Limit exists does not means it is continuous. Okay, so that is something you have to understand. Okay, right? So let's move on. So if you can understand these things, you are going to understand, or you are going to do a lot of complex software development, right? Or whatever the complexities in your life, you are going to handle it, right? Because you have that attitude. Okay, right? So here we have given some situations where you have to identify where it is continuous, where it is not continuous, right? For example, something like these places it is continuous, here it is not continuous. Why? Limit exists, but those two values are different, right? So remember that is the third condition. The limit exists and the limit and the value when you substitute must be the same. So here the limit exists because both are reaching the same value, but here the fx naught also exists, but that value is different from the limit value, right? So fx naught is this one, but the limit is this one. So therefore under this condition it is not continuous, right? So it's very interesting topic, right? Here of course the limit does not exist, right? Here the limit exists, but the value does not exist. Now you can see limit exists, value does not exist, limit does not exist, limit exists, value exists, but those are two different values, right? So you can see value exists, limit exists, but two different, therefore not continuous. Limit does not exist, therefore not continuous. Limit exists, but value does not exist, therefore not continuous, right? So there are situations like that, right? So when it comes to limits related to infinity, right, related to infinity, so something like that can happen. So that is what we discuss under sequence and series as bounded below, right? So it can reach to a particular value when you make this bigger and bigger, so it's getting closer and closer there. Or you can reach to a value like this. When you are making it bigger and bigger, it is reaching to close and close to the L, or squeeze to the L from negative side. This is from positive side, right? Right. Again it can be the negative infinity also, because in sequence and series always we go like this, but here in calculus, in relations, you can think of minus infinity as well. Okay, so it's getting closer and closer to the L when you are moving from bigger and bigger from the negative infinity, right? So here it's getting bigger and bigger and reach into L, but it never going to cross L. Okay, right? So then there are some useful limits that we want to remember, right? So that is 1 divided by xr when x is reach into infinity is 0. Just like 1 over x is 0, for any r value it is going to be 0, right? So it is not only 1 over x is 0 when x is bigger, 1 over x squared, 1 over x cube, all those things are also going to be 0, right? So this is here you are just subtracting a finite value. Now you can see that when x is reaching to a, this is going to be a minus a. A minus a is 0. So that means this is pretty much the same as this one, right? So this is pretty much the same as this one. So therefore, for example, I can write this kind of things now. I can write this kind of things now. What are those things? I can write something like this. Limit x tend to infinity, 1 over x is what? 0. Right? 1 over x is 0. If someone asks limit x tend to infinity, 1 over x squared, again this is going to be bigger and bigger, so something divided by bigger number is getting closer and closer to 0. So it can be cube, fourth, or whatever, right? And of course limit x tend to infinity or x tend to a, 1 over, so x, let's say x equal 5, 1 over x minus 5 is also what? 0. Why you can see that when x is getting closer and closer to 5, this is getting closer and closer to 0. So it's same as this. Same as this. Again it is infinity. Sorry, right? It is 0. Right? It is 0. Sorry, it is infinity. It is infinity. Right? So likewise, so this is, we are getting closer and closer to 0. Some number divided by 0 is infinity. Right? So it is something like, this is similar as limit x tend to 0, 1 over x. Right? This one, and limit x tend to a, 1 over x minus a, both are the same. Right? So here also it is getting closer to 0. When you are reaching to a, this is pretty much same as this one. Right? Pretty much same as this one. That means this is going to be reached to infinity. Right? Reached to infinity. Of course, when you have limit, you can just say equal. Right? Right. So I didn't get any questions yet. Right? So I hope you get it. Right? If you have any questions, you have to ask. Right? And finish this forever. Finish this forever. Okay. Right. So now we have some techniques. We have some techniques given by mathematicians. Right. So from Newton's time. The first one is, of course, if the given algebraic function does not result in any of the indeterminate forms, just substitute the value. I explained that. Right. So that is the case in reality. Of course, in the exams, they will not give that kind of questions much. But in reality, this is going to be the case. Right. So if it does not result in 0 divided by 0, infinite divided by infinite, you just substitute and find the value. That value is going to be the limit value as well. Right. So for example, if you take this one, when x tend to 2, x plus 1 divided by x minus 5, just substitute and see. When x is 2, 2 plus 1 is 3, 2 minus 5 is 3, 3 minus 3, that is perfectly okay. 3 minus 3 is minus 1. So you are done. So that limit is minus 1. You don't have to do anything, right? Because that is a happy scenario where you are not result in a indeterminate form. So this is another example. So just because 0, you don't have to worry. Now just substitute 0. 0 plus 1 is 1. Here 0. Of course 1 divided by 0 is not indeterminate form, right? So that is perfectly valid. 1 divided by 0 is what? Infinity. 1 divided by 0 is infinity. Because when things are getting closer and closer to 0, we found that this is getting bigger and bigger, right? So therefore the answer is infinity. Actually, though it is a limit question, it is not really a limit question. Okay, right? So actually, if you want to draw this, right, if you want to draw this, now you can see it's 1 divided by 0. If you want to draw this, you will see that when it is getting to 0, right, it is actually getting infinitely big. Actually, that is why, if actually this question is little bit wrong, you have to say whether you are reaching it from negative side or positive side. If you are reaching it from positive side, it is going to be for plus infinity. If you are reaching it from negative side, you are going to end up in negative infinity. Okay, right. Right. So let's take another example. 5 divided by x plus 1 when x is reaching to infinity. Again, just substitute and see. Right. 5 divided by infinity plus 1. Of course, infinity plus something is 1 is a finite value, that is infinity. That is 5 divided by infinity. Something divided by infinity is 0. So you don't need any technique. Something divided by infinity is what? So that we discuss. Right. something divided by 0 is 0. Sorry, something divided by infinity is 0. So you just use it. You just use it. It is not indeterminate form, right? So it is not indeterminate form. Something divided by infinity is 0. Therefore, answer is what? 0. Right? Answer is 0. If you want, you can just draw this also. So there are tools. Of course, you can use your graph paper, whatever. But there are now a lot of tools available. So I will just show one of the tool. So I'm just going to plot 5 divided by x plus 1. Okay. So for the WhatsApp group, I will add this link. How to graph these things. So I have the link, hopefully. Yeah, graph calculator. So don't learn things in the way that we learned in 1990s. You are in 2020s. A lot of online resources are available, right? For example, so still it is getting loaded. So I will give the link, right? So for example, if you want to plot y equal x, something like this. If you want to plot y equal 2, so this is y equal 2 graph, like constant function, right? So if you want y equal x, that is with 1. So now if I want another one, I want y equal, so that is what you did in your semester 1. Semester 1 boru kala nan, then boru tamai. You can see it is shifted by 1, right? If it is 2x, 2x means what? This gradient is even steeper, right? Even steeper. I'm not looking at this, right? It's going to be even steeper. Y equal 2x. Now you can see it's getting steeper. If it is half f x or whatever, it's going to be less steeper, right? Less. Y equal, so a ඇඟේ තියෙන්න ඕන මැච් කරනවා නම් හරි. Let's say half x, sorry, not there, half x. Now you can see this is y equal x, this is y equal 2x, this is y equal half x. Now what about y equal minus x? That is perpendicular to y equal x, right? So අන්න එහෙම ඉගෙන ගන්න යා මේ කළු ලෑල්ලේ පොතේ ඉගෙන ගන්න කොහෙද මේ 2020 එකක්. Say y equal minus x, right? So something like this, right? So if I want so now let's delete everything. Right, so let's have something like y equal x squared, x squared, right? So something like this, right? So if I want something like y equal minus x squared, right? So something like this. Right? So if I want something like y equal x squared plus 1, right? So now we can see that y equal x squared is this, y equal x squared plus 1 is it's shifted 1 above, right? Shifted 1 above. So likewise you have to understand this. Now anyway, so let's look at our one now. So I'm going to delete all those things. So then only you will understand these things are, yes, these, otherwise you just get an answer, but you don't know what is happening. You don't know what is happening. Right? So let's plot this one that we have been discussing. Y equal 5 divided by x plus 1. Right? 5 divided by x plus 1. So where is that graph? Okay, I want to look at this. Right, now you can see this is the graph, right? So what we got as a limit is when x is reaching to infinity, what we got is what? 0, right? So what we got is 0. Of course you can see it's getting closer and closer to what? It's getting closer and closer to the 0. You can see it's not never going to go beyond that. It's getting closer and closer to 0. That is exactly what we got by using substituting this, right? So that is exactly what we got here. So it will take a lot of resources, so just wait until I get the PDF. Right, so that is what I got. So that you can see that the value of 0 is not a wrong value. Right, value of 0 is not a wrong value. When you plot it also, you will see that it is getting close and close to 0. Right, so here we use that number divided by infinity is getting close and close to 0. Actually, if it is plus infinity, it is getting close and close to 0 from positive side. If it is negative infinity or the 0 from negative side, it is going to be close and close to the 0 from the other side. Okay, right. Actually, I have made a mistake here. It has to be what? Extend to infinity. Yeah, extend to infinity. So I have made a mistake. I will update and upload it. So it has to be infinity. When it is reached to infinity, it is getting closer and closer to the 0. Okay. So it has to be plus infinity or negative infinity. Right. Right. Now we are going to discuss. So that is Rowley. You just substitute and find the limit. Right. You just substitute and find the limit. Now we are moving to the some techniques. So we have a few techniques. So I have just made it. So this is not actually technique. You just substitute and get the value unless it is conflicting situation. So we have technique 2 and also we have technique 3. Right? There's a technique 4 also that we will be discussing when we do the differentiation. That is a L'Hopital rule. Right? So technique 4. Since the technique need derivative values, this will be discussed under differentiation section. So those techniques you have to learn, then you are done with limits. Okay, right. So let's look at those techniques. So the mathematicians found that some techniques, right? So the technique 2 is, if you encounter something like 0 divided by 0 or infinity divided by infinity, then factorize and eliminate the common factors. Then it might result in a situation where this is no longer there. Then you just substitute. You can see nothing big, right? So what they found is, if you have a situation like this, just see whether factorize and then eliminate those factors, then you might end up with something which is not like this. Then you just substitute and find the value. So that is a technique 2, right? That is a technique 2. So let's look at something like this, right? So we are asked to find limit x tend to 1 x squared minus 1 divided by x minus 1. So now if I just substitute, that is the first thing you want to check. If I just substitute, what will happen? 1 squared is 1, 1 minus 1. Now the top one is, the numerator is 0. Here 1 minus 1, the denominator is also 0. Now we are in trouble because 0 divided by 0, it's indeterminate form. We don't know what is that. So now you can see, you can't just substitute and do that, because 0 divided by 0 is not 1, right? So remember, 0 divided by 0 is not 1. 0 divided by 0 is one of the indeterminate form. So therefore what we are going to do is, now let's see whether can we apply this technique. So this technique says what? If the limit of an algebraic fraction results in 0 divided by 0 or infinity divided by infinity, then factorize and eliminate the common factors. It may, there is no guarantee, it may result in a determinate form. So if it results in determinate form, you just substitute and do it. Okay, right. So that is something even a grade 2 student can understand. Okay, right. So now we are in trouble. So what we are going to do is now factorize, because it ended up in 0 divided by 0. But I can see there are factors. X squared minus 1, I can write it as x plus 1 into x minus 1. Of course, the denominator we have the x minus 1. Now you can see these factors can cancel out. But remember, very important thing, you have to write that x is not equal to 1, because we are not finding the value when x equal 1. We try to find a value when x is reach into 1. Those are two different things, right? So whenever you cancel out these things, you have to write that x is not equal to 1, because we are not interested about when x equal 1. We are interested about what happens when x is reach into 1. Okay, so therefore I can cancel it out. Now it is just x plus 1. Of course, now it is not 0 divided by 0 anymore. I can just substitute now x equal 1. 1 plus 1 is what? 2. Answer is 2. Answer is 2. Now you can see, earlier it was 0 divided by 0, but now I got the answer using this technique. Using this technique, I got the answer. My answer is 2. Right? My answer is 2. Actually, this is a very very simple questions, sort of a tricky question. Actually, tricky means that actually you can see that actually if you factor it out, it is actually x plus 1, right? X plus 1 graph. But in that case also you can get it using that, because it is x plus 1 graph hidden in a complex algebraic expression, right? So of course if it is x plus 1, when x is 1, it is going to be 1 plus 1 2, 1 plus 1 2. So that answer is correct, that answer is correct. You just factor it out and then substitute. Okay, so let's take another example, something like this. So here you can't see the factors straight away, right, because it's not squares are there, but you can see that in this kind of situation what you can do is, if you substitute anyway, if you substitute, what will happen? 2 minus square root of 4 is again 2, 2 minus 2 is 0, 4 minus 4 is 0, again 0 divided by 0. Now again you have to check whether can I factorize. In this kind of a situation, if the factors are not obvious, another technique you can do is you multiply, right? You multiply. For factorizing some fractions, multiplying top and bottom by conjugate can help. So I have given you that is part of the technique. If the factors are not obvious, try doing this. Right, conjugate means if you have x plus a, conjugate of x plus a is x minus a. If you have x minus a, conjugate of x minus a is x plus a. So try multiplying both denominator and numerator by that, because if you multiply both denominator and numerator by the same value, you are not going to change the value. Okay, so here what we do is 2 minus root x is there, I am going to multiply it by 2 plus root x, right? 2 plus root x both sides. Now all of a sudden you have 2 minus root x into 2 plus root x, right? So that is difference of squares, that you can write it as 2 squared minus root x squared, right? 2 squared minus root, of course the bottom side you have to keep the 2 plus root x. Now it is 4 minus x is there, 2 squared is 4, root x squared is x. Now all of a sudden you can see it's factor out, 4 minus 6 and 4 minus 6 cancel out. Now it is 1, again you have to write that x is not equal to 4, right? So again that is 1 divided by 2 plus root x, right? So now I can substitute 4 for root x, that is root 4 is 2, 1 over 2 plus 2 is 1 over 4. Now I got the answer. Earlier it was 0 by 0, but by using this multiplied by conjugation, I managed to factor it out and I got the value as 1 over 4, right? So those are well known techniques, right? ඔයාට හිතන්න පුළුවන් දැන් මේ වගේ අපෝදා විදි 100 ගණක් නැහැ. ඔය ටෙක්නික් දෙක තුන විතරයි අපි දාන්නේ. හරි? මේක ටෙක්නික්ස් තියෙනවා. ඕගොල්ලන්ට සිලබස් එකේ ඒවා නැහැ. හරි? Right, so that is another technique, right? Factor it out. If the factors are not obvious, try to multiply it by the conjugate, then it might again factorize. Okay, so we have another technique, right? That technique is used only when you are finding the limits to the infinity, right? You are trying to find a limit to a infinity and it is an algebraic fraction, right? It has to be algebraic fraction, right? And limit, you are trying to find a limit to infinity. In that kind of a situation, again first try to apply the infinity and see whether it's work, right? For example, if you get something like this, right? So therefore don't come to technique 3 straight away. If you have something like this, limit x tend to infinity, x squared plus x divided by 5. Now you are asked to find the value or the limit. So you have no issue, just substitute and see first, because that is the technique one. So infinity squared is infinity plus infinity divided by 5. Infinity plus infinity is, remember, adding infinity to another infinity is still infinity. Infinity divided by 5. So what is infinity divided by a finite value? Infinity. So answer is infinity. No issue, right? Because remember, infinity divided by constant is infinity. So we mentioned everything, right? Our gaps here in infinity divided by constant is common sense. Okay, I forget to mention that. I mean within 10 no, na? So infinity divided by, so I have infinity multiplied by k, right? Actually why we are not telling is this, if this k is a fraction, it is become infinity divided by k. Anyway, I will add that as separate thing also, right? So infinity divided by k is also what? infinity, because infinity divided by a finite value is not going to change it. Still it is infinity, right? You have a huge thing, you are dividing it to two people, right? You are dividing it to two people, still it is infinity, right? So actually uh, when I was preparing this note, right, when I am preparing this note, uh, I just saw a Facebook, not a Facebook article saying the 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 world's richest person, the world's richest person, who is the owner of Amazon, he got divorced. Part of his wealth was divided to his ex-wife, but still, even today, he is the richest person, because that part is not going to make it him the richest person. So same thing, infinity divided by a finite value, still it is infinity, right? Of course, he doesn't have the infinite wealth, but still he managed to retain his number one spot. So then what about the infinity, right? Okay, so this kind of situation, no issue, but there can be a situation where you will ended up in infinity divided by infinity, right? So let's look at that kind of situation, right? Something like this. Now if you just substitute infinity, it will be infinity squared plus 2 divided by infinity. Now infinity squared is infinity, adding something to the infinity is again infinity, and here also denominator also is, now you can see it is infinity divided by infinity. Now we are in trouble, now we are in trouble, right? It is not something divided by infinity or infinity divided by something, it is infinity divided by infinity. Now we are in trouble. So this technique is to this kind of a situation, right? When finding limits to infinity of an algebraic function containing the variable in both numerator and denominator, divide both numerator and denominator by the higher power of the variable and then find the limit. So here this is not going to work. So what you have to check is what is the highest power of your variable. In this case, highest, here the power is 1, here the power is 2. You have to divide the entire expression by the highest power. So in this case, highest power is x squared. Divide your numerator by x squared, divide your denominator by x squared, then only apply the limit. So that is what we are going to do. So that is the technique 3 says, right? So what we are going to do is, because highest power is x squared, I am going to divide this expression by x squared, this expression by x squared, because it is not going to change, right? So dividing means you have to divide each and every term. X squared divided by x squared plus 2 divided by x squared. Here x divided by x squared. Of course, x squared divided by x squared is 1. 2 divided by x squared, just keep it as 2 divided by x squared. Here 1x cancel out, it is 1 divided by x. Now you substitute the infinity, right? So here it is 1. Something divided by infinity squared is something divided by infinity. Something divided by infinity is what? 0. Something divided by infinity is 0. Here also something divided by infinity is 0. Now 1 plus 0 is 1. 1 divided by 0. Now we know what is 1 divided by 0. 1 divided by 0 is what? Infinity. Of course the answer is infinity. So earlier we got something called infinity divided by infinity, which we can't figure it out, but now we got answer as infinity. So answer is infinity. So sometimes when you do that, you might get something like 0 or you might get something like 2. So that is possible, right? So though it is looks like infinity divided by infinity, ultimately the answer is infinity. But what you can do is you can plot this and see. Now it says when x n infinity, the value of y or fx is infinity. Now let's plot this. X squared plus 2 divided by x. Right, remember it is x squared plus 2 divided by x. Okay, so let's take this one. So let's remove this. Right, y equals x squared plus, so what is our expression? X squared plus 2 plus 2, let's have square, divided by x divided by x. Right, so that is my expression. Now let's see. Now this is my graph, right? X squared plus 2 divided by x. If you want, if you have graph paper, you have to just add some values and plot it. Now you can see when x is getting bigger and bigger, when x is getting bigger and bigger, right? So when x is getting bigger and bigger, what happens to y? It is getting bigger and bigger. That means when x is reaching to the infinity, plus infinity, my y is getting reach into the plus infinity. Of course that answer is correct, right? So what we got using that techniques and what you see in the real graph is same. Okay, you can see it's getting bigger and bigger, right? It's getting bigger and bigger. So that answer is correct. So answer is infinity. That is correct. Okay, so that is how you learn it, right? So yes, answer is infinity, correct. If it is minus infinity, what happens, right? What happens? Look at the graph first. So minus infinity means we are going like this. We are going like this. So answer should be what? It must be minus infinity. Now let's look at that, because here it was not mentioned. If it is not mentioned, you can take it as plus infinity. Now what will happen? Now again you have to divide it by here, because now here you can see something divided by infinity is 0. So this is so let's take it like this. Here we don't have to change up to this one. So here 1, right? Because it's minus infinity. Minus infinity. Now it has to be minus infinity. Minus infinity. Minus infinity. So something divided by minus infinity is of course 0. 0, right? Here it is 0. 1 plus 0 is anyway 1, but this is 0 because it is minus infinity. We are reaching it from negative side. So when you are reaching it from negative side, it is going to be what? Negative infinity, right? Remember when we are, so remember, just remember this. Now this is infinity, yes, but minus infinity means you are reaching to the 0 from negative side. Negative side. Therefore 1 divided by 0 from negative side is negative infinity. So that we discussed earlier, right? 1 divided by 0 from negative side, right? So something divided by 0 from negative side is what? Negative infinity, right? So that you can see, you can explain anything, right? So that is the beauty of maths. That is the beauty of maths. Only thing is, if you have gaps, ඔයා අතනින් කෑල්ලක් අමතක කරලා යනවා, මෙතනින් කෑල්ලක් අමතක කරලා ඊට පස්සේ maths නිකන් maths කියන එක නිකන් භූත විද්‍යාව බවට පත් වෙනවා. කෑලි අතෑර ගිහලා maths ඉගෙන ගන්න බෑ. හරි, ඉගෙන ගන්නවා නම් හරියට ඉගෙන ගන්න, භාග ඉගෙන ගන්න බෑ. භාග ඉගෙන ගන්න බෑ. භාග ඉගෙන ගන්න ගියාම maths කියන එක නිකන් ආර්ට් බවට පත් වෙනවා. හරි, maths ආර්ට් නෙමෙයිනේ. So ඒක තමයි වෙලා අරගෙන ඔක්කොම ටික කරන්නේ. වෙලා අරගෙන කරන්නේ ඕගොල්ලන්ගේ confidence build කරන්න. ඔයාගේ exam එක pass කරන්න නෙමෙයි. හරි, අපිට ඕන confidence එකක් තියෙන වැඩක් කරන්න පුළුවන් මිනිස්සු. හරි, වැඩක් කරන්න නැති සාහිතිකයක් විතරක් තියෙන බූරුව වැඩක් නෑ අපිට. හරි, බූරුව තමයි ඒගොල්ලෝ. හරි, සාහිතික තියෙන වැඩක් කරන්න බෑ. Right. So you can see that this technique works. This techniques perfectly work. So therefore we can use it. So what happens if it results in infinity divided by infinity? You divide your denominator and numerator by the highest power, right? So let's take one more example. This one, right? So it says specific minus infinity, right? So again, if I just roll it, apply infinity, it is going to be what? Minus infinity to the power 2 plus 3 times minus infinity to the power 3, 2 times minus infinity, actually it is not the square, minus 6. So you will get, here you are going to get infinity minus infinity. So that is again we are in trouble, right? You can see infinity minus infinity is something not determinant, right? So here also infinity minus infinity. So you can see it is not determinant. So we can't do that. So that means you can't just roll it, substitute infinity, right? So then what we have to do is again look at which one has the highest power. Which one has the highest power? Of course the cube is there. Then divide your denominator and numerator by x cube, right? So that means you have divide each term by x cube. In that case we are going to get 1 over x here, 3 divided by x squared here 1, here 3 divided by x, actually this must be square. Actually this, yeah, x divided, there's 1x, there's a cube, x squared, here 6 divided by x cube. Now just substitute minus infinity, right? Minus infinity. So something divided by infinity is 0, right? So here 0, here 0, here 0, here 0, here only we are going to get 1. So that means 0 divided by 1 is 0. Now you can see earlier we got something like infinity. This one we got 1, 0, right? 0, right? So if you plot this, what you are going to get is 0. So now let's plot it. X squared plus 3x. So that is something for you to understand, okay? You don't have to plot it to get the answer. X squared plus 3x divided by x cube plus 2x x cube plus 3x, sorry, x cube plus 2x minus 6. Right, so that is my thing. So I think I have to zoom it. Right, so you can see the graph is there. So this is the graph, right? So so what we wanted is what? When x reached to minus infinity, what we got is what? What we got is when it reached to minus infinity, what we got is 0, right? So let's see whether it's 0. Yes, when we are moving to minus infinity, you can see it's getting closer and closer to 0, right? What පේනද මේ ලස්සන graph එකක්. හරි. මම මේක zoom කරොත් එහෙම. මට පේනවද? මෙයා 0 වලින් ඇවිල්ලා මෙහෙම ඇවිල්ලා මෙහෙම උඩට ගිහිල්ලා හරි උඩටත් යනවා යා ආයි පහළට එන්න පටන් ගන්නවා දැන් මෙයා හරි පහළට ඇවිද්දි මේ graph එක අර plot කරද්දි වෙච්ච ප්‍රශ්නයක් අන්ද මේ අර software එකක්නේ ඇත්තට මේ cut වෙන්නේ නැහැ මේක පාට cut වෙලා වගේ වඩ පේන්නේ cut වෙන්නේ නැහැ මෙයා එන්න බිඳුවට ලං වෙනවා එන්න බිඳුවට ලං වෙනවා so it's getting closer and closer to 0 when you reach to minus infinity is going to getting closer and closer to 0 so that is what exactly what we got yes 0 right so you use this technique so how many techniques we use if it is not indeterminate form you just substitute you are done if you get something like 0 divided by or infinity divided by infinity and if your limit is not something to do with infinity just try to figure out whether you have common factors if common factors is not there try to multiply it by the conjugate and see if that is also possible right of course you can't find limit everyone using these techniques for that you have another technique called L'Hopital rule that we will be discussing after differentiation of course if it is something to do with infinity if you feel like you are getting infinity divided by infinity or infinity minus infinity or something like that divide by the highest power of that value then you get something like this then you apply it using the 1 over infinity is 0 then the value you get is it might be infinity it can be 0 or it can be a value so it can even be value right so like 5 let's take another example and we'll finish after this say I have something like this so look at this beauty of this subject okay so let's see I want to find this limit x tend to infinity 2x squared plus 5 divided by 3x squared plus x right now what is the value of this right what is the value of this so let's see if I just now what is the first technique just substitute and see now if I just substitute what will happen 2 into infinity squared is infinity that is to infinity plus something is infinity divided by here infinity squared is infinity plus infinity plus infinity is infinity divided by infinity now you don't know what is that value right so now we are in trouble now let's apply the third technique so what is the highest power square right? X is there square is the highest power is square now I'm going to divide it by x squared so that is limit x tend to infinity 2 when you divide by x squared, it is going to be 2 plus 5 divided by x squared divided by x squared to x squared is going to cancel out. 3 plus x divided by x squared is going to be 1 over x. Now let's apply the infinity. 1 over infinity is 0. That means 2 divided by, here also 1 over infinity is 0. It is, answer is what? 2 divided by 3. Now you can see we got something like 2 divided by 3. Right? Originally it is infinity divided by infinity. But when applying this technique, what we got is 2 divided by 3. So let's see whether this answer is correct. Now you can see. Let's plot this. 2x squares, 2x. Now without plotting we found that value. That is the beauty of calculus. 2x squared plus 5. Let's plot it. 2x squared plus 5. So I'm just changing this. 2x squared plus 5 divided by 3x squared plus 6. 3x. If I want to do some powers, I am using the hat in my keyboard. You can't see 3x squared, and then I will just take the cursor again, plus x. Right, so that is my expression. So what I'm supposed to get is, when x is getting bigger and bigger, it must reach to 2 divided by 3. Now let's see. Now let's zoom it again. Now what we got is 2 divided by 3. Okay, right, you can see it is not reaching to 0 now. Right, it is not reaching to 0. Right, so it's reaching to something like 2 divided by 3. Right, so it is not going to reach 0. Right, so of course you can't see it, but if you apply some values, right, right, if you apply some values, you will see that it is getting close and close to the 2 divided by 3. 2 divided by 3. Right, if you apply something like 1 million here, you will see that it is not getting 0. It is not going to go beyond, it is not going to go less than 2 divided by 3. Right, 2 divided by 3, value is 2 divided by 3. Okay, so that is how we use concept called limits to find out these kind of things. Okay, right, so I hope you get the idea. So I did it very slowly. I deliberately take a lot of time, because I am not going to take this much of time for differentiation, because foundation we take a lot of time. On top of foundation, of course, you can build your own thing. Of course, now you can learn differentiation by yourself. I have uploaded the document. Right, so what we are going to do is, tomorrow we are going to do the differentiation, and of course if we have time, we are going to do some past paper questions as well. Okay, so I hope you got it. Right, so this is the most difficult question. Some people think this is not a difficult question, but the only thing is, you must have that attitude and courage to understand these things. Of course, those people who have that kind of courage are going to have courage to do some really complex things in the real world as well. Software, it can be software development, or when you face some difficult situation in your life, you don't get upset. You know how to handle complexities, right? Handle complexities and get over those things, how to understand complex things. Okay, right, so I hope you got it. So we'll stop it at this point. So tomorrow we are going to discuss the differentiation. So that is where the usage of limits comes. Okay, right.